quickly as possible as well. All right, so at 7.4, we are adding and subtracting rational expressions with unlike denominators. And if you remember in 7.3, what was nice was our denominators were common, so we didn't have to do anything to them. But what you'll see with the problems we're covering now, those denominators will be different. And the way they'll present the problem to you is they'll present it horizontally. But when I'm solving fractions, I like to do them vertically. So main thing to notice is these denominators right here are both different. So you have 5z and 2z. So what you want to do always, the first thing is determine what is my LCD, what is my lowest common denominator between 5z and 2z. We start with the 5 and the 2, the numbers in front of the variables. And you're thinking of those multiples, really. And remember, like I always say, start with the higher number. And you could always try that first number. Does 2 go into 5? It won't go into 5 perfectly. So you go to the next multiple of 5, which would be 10. And would 2 go into 10? Yes, 2 does go into 10. So as far as that coefficient, the first part of the coefficient of our LCD is going to be 10. And then we're looking, they both have the same variable, and it has the same power. So we're just going to go ahead and keep that. Now, if one was squared and one was to the 5th, remember we'd have to use the one that's to the 5th. We'd have to use whatever the highest exponent of the variable we see. So again, like I said, I'm going to solve these vertically. So when I write this problem, I'm going to write it like this. Okay, so vertically. And again, we've already determined what our LCD is. It is 10z. So I kind of write that denominator that we're going to use, I'll write it all 3 places. And then the question is, what do I have to do, start with this bottom one here. What do I have to multiply to 2z to get it to 10z? And the answer is I'd have to multiply that by 5, because 2 times 5 would get me to the 10. And remember, whatever I do to the denominator, I must also do to the numerator. And it'll take a second sometimes to focus. So 4 times 5 would then give me 20. So that's how we rewrite that bottom fraction. So we go to the 25 over 5z. What do I need to multiply to 5z to get it to 10z? Again, 5 times what would give me 10? And the answer is 2. So again, I'm doing that both places, my numerator and my denominator. 25 times 2 would give me 50. So again, we're keeping the denominator. We're not adding 10 and 10. It just remains 10. But we add the numerators. So what is 50 plus 20? 50 plus 20 would give me 70. So again, your last step is to determine, is that reduced? Is 70 over 10 reduced? No, I can reduce that. 70 over 10 would give me 7. And again, you keep the variable in the denominator. So the answer then would be 7z. And I know some of my z's, I didn't draw my line through them, just so they don't look like 2's. So there's really like 4 different types of problems you're going to see on this homework. That was the first one, and there's 3 more that I'll also give you examples for those as well. All right, so this is our next example. Again, you'll notice these denominators are not the same. So we cannot add these the way they are. And also be careful because some of these problems are going to be addition and some of them are going to be subtraction. So again, we're looking at the x and that 4x squared, and we need to determine what is our lowest common denominator. What would our LCD be of those two things? Keep in mind, even though you don't see that coefficient there is 1. So when we're looking at numbers 1 and 4, if we're just dealing with the coefficients, what number will 1 and 4 both go into? The answer then is 4. So that's how you determine the first part of your LCD. Now we look at the variables, and we have x by itself, which is exponent of 1, and we have x squared. So remember, you have to pick the exponent with the most, with the higher number. So in this case it would be x squared, because remember, if we just picked x squared would not be able to go into x. Okay, there's nothing, I can't multiply, I can't take that x off, I can only add on. So that's why you always pick whatever the higher of these exponents are. So now we've determined our LCD of these two denominators is going to be 4x squared. So at this point, like I said, I like to do these problems vertically. I think on the PowerPoint, you'll notice they do them kind of horizontally. But again, I like to set mine up vertically. So once I determine that LCD, I can write that in all three of those places. And then I just got to figure out, well, what I got to multiply to get my LCD to be 4x squared. And if you notice on the first one here, it is already 4x squared, right? So I don't have to change this bottom one at all. So it just stays the same. 3 over 4x squared. But if you look at the top one, okay, what do I have to multiply here? First of all, to get it to 4, because remember there's a 1 here. So the first thing I got to multiply is that I have to multiply that by 4. And how am I going to get the x to become an x squared? I would have to also again multiply it by a x as well. So that would give me, it would turn into 4x squared. So again, whatever I multiply to the bottom to get to the LCD, I have to do the same thing to the top. And again, 2 times 4x would give me 8x. So again, what are we doing? We are adding, we keep the denominators, and we add the numerators. So we're going to add 8x plus 3. But what you will notice is these are what we call unlike terms. So we cannot add that. That doesn't become 11x or anything crazy like that. It's just they stay separate, and it stays 8x plus 3 over 4x squared. There's nothing we can simplify. Even though that 4 will go into the 8, the 4 doesn't go into the 3. So really we have nothing. We just stop right there. That would be the answer to this solution. Alright, so this is the next type of problem you're going to see on this lesson. Again, you'll notice the way we start out is we look at these denominators. And in this case we have 7 and 14. So they are not the same, so we need to figure out what is going to be our LCD of between 7 and 14. Well, again, they don't have variables, they don't have letters with them, so we're just dealing with these numbers. Okay, so we're looking for a number, the smallest number that both 7 and 14 will go into. So if we start with a higher number, we ask ourselves, will 7 go into 14? And yes, 7 times 2 would give me 14. So it's kind of not that hard to figure that out. Okay, so our LCD is going to be 14. Again, I like to do these vertically, so I'm going to rewrite them. Vertically, and again, what do we determine our LCD to be? 14. So we'll put that 14 all three places. And kind of before I go on, again, I want you to remind you, this problem is a subtraction. So make sure when you do your answer, don't assume all of them are addition. You got to check to see. So we just got to make sure we enter this as our answer as a subtraction problem. All right, starting with this fraction here. we want the denominator to be 14. Well, it's already 14, so I'm not going to change this fraction here. I'm just going to leave it as 7x to the third. But this top one, I got to get this 7 to 14. Well, what do I have to multiply by 7 to get it to 14? That's what you're asking yourself, and the answer would be you got to multiply it by 2. If I multiply the bottom one by 2, I have to multiply the top by 2 as well. There it goes. 4 times 2 would give me 8x to the 6. So again, our denominator, we've already kind of established the LCD is 14, and we are adding our numerators together. And again, these are unlike terms because this is x to the 6, but this one is x to the third. To be like terms, they not only have to have the x variable, they have to have the same exponents. Okay, so if they are unlike terms, all you do now is just write 8x to the 6, and make sure you put the subtraction sign, minus 7x to the third, and you are done. There's nothing that we can simplify beyond that. Okay? And so there's one more final type of problem that we will see, and I'm probably going to do that example twice because that one's probably a little more complex. Alright, so this is the last type of problem you're going to see, and I really only got one of these. The lesson itself is only 10 problems. But this one's a little bit different than from some of these other ones. What we'd like you to notice right away is that really the way this fraction is set up, it is not simplified. So there's a lot of different ways we can solve this problem, but one of the easier ways to do it is to simplify this fraction first. In other words, what can I factor out here of 7x and 7? You know, they both have a 7 in them. So I can take this, I'm going to kind of do it off to the side. Okay, if I factor out a 7 from that, it becomes 14 over 7 times x plus 1. Okay, and that's just pulling out a 7 from both of these. All right. And then once I do that, what do you notice here? This can easily be simplified, right? 14 divided by 7. What is 14 divided by 7? The answer is 2. So now, this fraction here, that was a little more complex, simplifies to just 2 over x plus 1. And what's nice about that, once I simplify it, what do you notice about these denominators now? Both our denominators are the same. So I'm going to rewrite this one in its simplified form as 2 over x plus 1. So now if our denominators are the same, I really don't even have to do these vertically because I know my denominator is x plus 1. I'm not going to change either of these fractions now, and it's just a matter of doing what is 8 plus 2. And 8 plus 2 would give me 10. All right. So we'll do one more of those because I know they're, like I said, a little bit different. The other one, when I did a similar question, it gave me 5 over x plus 2. We'll call this example 5. Plus 15 over 5x plus 10. And again, what you'll notice is, okay, there's nothing I can factor out of this one, but if you look here, 5x plus 10, what can I pull out of 5x plus 10? What goes into both 5 and 10? The answer is 5 will go into both 5 and 10. So once I factor out that 5, this becomes x plus 2, and I still got the 15 on the top. But 5 will go into 15, right? 15 divided by 5 would give me, that would just simplify it to 3. And then what's left on the bottom? Here, x plus 2. And again, what's nice, again, we're taking this fraction, we're going to rewrite it as what we got over here, 3 over x plus 2. And when I do that, come back to me. When I do that, you'll notice now we have common denominators. Okay, and once we get that, now we can add them together the way they are. We keep the x plus 2, and we just add the numerators. What does 5 plus 3 give me? 5 plus 3 would give me 8, and I am done with that problem. So again, guys, this is kind of going to be